Hello students, how are you all? I hope you all are doing very well. So welcome to the science class. I'm a digital science mentor and today we are going to start a new chapter number 4, metal and non-metals. We use a number of metals in our daily lives. Some of the commonly used metals are iron, aluminium, copper, etc. Metals can be distinguished from non-metals on the basis of their physical and chemical properties. Some examples of non-metals are hydrogen, sulfur, carbon, phosphorus, chlorine, bromine, iodine, oxygen, etc. So now let's see the next topic, that is physical and chemical properties of metals. It will be seen that iron nail, copper wire, aluminium foil change shape on heating. They could be beaten to thin sheets. This property of metal by which they can be beaten into thin sheets is called malleability. Gold, silver and aluminium are most malleable metals. Non-metals are brittle and cannot be beaten into thin sheets or so. You will notice that the metals are good conductors while sulfur and coal are bad conductor of electricity. Metals are thus used for making electrical cables and wires. Graphite, which is a non-metal, is an exception to the rule that non-metals are poor conductors of electricity. So now let's see the next topic, that is thermal conductivity. Metals are also a good conductor of heat and are therefore used for making cooking utensils. Now you know why you cannot hold a hot metallic pan without hurting yourself. Thus, cooking pans are provided with wooden or plastic handles. Silver is the best conductor of heat, but since it is expensive, it is not used much. Next best is copper. Now let's see, that is physical state. Metals are generally solids except mercury and gallium, which exist as a liquid at room temperature. Non-metals are usually solids or gases at room temperature. Only bromine exists as liquid at room temperature. Now let's hardness. Most metals are hard. The only exception being sodium and potassium, which can be easily cut with a knife. Non-metals are generally soft, with diamond being an exception. It is the hardest known substance. C. Ductility. The property of metals by which they can be drawn into wires is called ductility. Non-metals are brittle and cannot be drawn into a wire. Next is your sonority. The ability of metal to produce ringing sound is called sonority. You must have heard different sounds when an iron plate or a metal coin is dropped on the floor. Metal objects produce a ringing sound when struck hard. Metal are sonorous. This is the reason objects like wind chimes and bells make a ringing sound. Non-metals are non-sonorous. They produce a dull sound when struck with a hard object. From the above, it can be concluded that materials which are hard, lustrous, malleable, ductile, sonorous and good conductors of heat and electricity are called metals. Examples are iron, copper, aluminium, gold, silver, etc. In contrast, some materials are soft and dull. They break down in a powder when hammered, are poor conductors of heat and electricity and are not sonorous. The materials are called non-metals. So, chemical properties of metal and non-metals. So first we will see reaction with oxygen. Metals react with oxygen to form their oxides. Different metals react with oxygen under different conditions. When metal will react oxygen, it will produce metal oxide. Sodium reacts with oxygen at a room temperature to form sodium oxide. Magnesium on heating burns into air to form magnesium oxide, that is also known as MgO. You have already studied how rust is formed in the... Now The metallic oxides formed are basic in nature and turn red litmus solution blue. Have you seen a greenish deposit on the surface of copper vessels when exposed to air for long? This occurs due to the formation of a mixture of copper hydroxide and copper carbonate, which is green in color. When the copper reacts with hydrogen and here you can see a chemical formula. When copper reacts with hydrogen, oxygen and carbon dioxide, it will produce copper hydroxide and copper carbon dioxide. So now let's see non-metals. They also react with oxygen to form non-metallic oxides. When non-metal react with oxygen, it will produce non-metal. So sulfur burns in oxygen form sulfur dioxide. Here you can see the chemical formula. S plus O2 will give us SO2. And the amazing fact is that sodium reacts with oxygen very fast even at a room temperature. Hence, it is stored in kerosene oil. When sulfur dioxide is dissolved in water, sulfurous acid is formed which turns blue litmus red. Now, here you can see the chemical formula, that is SO plus H2O will produce H2SO4, that is sulfur dioxide react with water will give us hydrogen sulfate. Now generally oxides of non-metals are acidic in nature. Now let's see reaction with water. Metals react with water under different condition. However, most metals produce a metal hydroxide or metal oxide and hydrogen gas. Here you can see when metal react with water, it will produce metal hydroxide or hydrogen gas. After that, when metal react with water, you can say that it will produce metal oxide plus hydrogen gas. Sodium react with most vigorously, followed by magnesium, aluminium, zinc and iron. Generally, non-metallics do not react with water, though they may be reactive in air. The activity, you have to perform that activity. Now, phosphorus is very reactive non-metal. It easily catches fire when exposed to air. Hence, it is stored in water to prevent its contact with atmospheric oxygen. Now, let's see the next, that is reaction with acids. Metals react with an acid to form a salt and hydrogen gas is produced. When a burning matchstick is brought near the mouth of the test tube containing metals, a pop sound is produced. This is due to the production of hydrogen gas. Non-metals do not produce hydrogen gas. Copper does not react with hydrochloric acid even on heating, but react with sulfuric acid. Now let's see reaction with bases. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 to 4 pellets in a teaspoon of water. Use a plastic spatula taking out sodium hydroxide droplets. Drop a small piece of aluminium foil in it. Bring a lighted matchstick near the test tube. Observe what happens. You will hear a pop sound due to the presence of hydrogen gas. The above activities show that metals react with sodium hydroxide to produce hydrogen gas, and the reaction of non-metals with bases are. Let's see displacement reaction. In displacement reaction, a more reactive metals replaces a less reactive metal from its compound. However, vice versa is not possible. A less reactive metal replaces a more reactive metal. So, now let's see uses of metals and non-metals. Metals. Iron is used for making bridges. Now, let's see uses of metals and non-metals. So, metals, that is first iron. It is used for making bridges, locomotive, ships, rail, utensils and surgical instruments. Gold and silver for making jewelry, copper, electrical wires and cables, utensils and coins. Aluminium, electrical wires and cables, utensils, alloys, picture frames. Zinc as a protective coating for iron. Then we can say thus that metals are used in making machinery, automobiles, trains, aeroplanes, furniture, industrial gadgets, cooking utensils, jewelry, etc. Now let's see non-metals. So first is a phosphorus. In firework industry, matchsticks, fertilizers. Graphite in pencils, zinc carbon, batteries. Iodine, iodinized salt, tincture of iodine, that is antiseptic. Next is a chlorine for bleaching, purifying water. Oxygen for respiration and combustion. Sulfur in manufacturing, gunpowder, sulfuric acid and sulfate. Hydrogen as a fuel for synthesis of ammonia and methyl alcohol. Hope you have understood all of these things. So now let's wrapping it up. Let's see some points. So metals are lustrous, malleable and ductile. Non-metals do not have these properties. Metals are generally good conductors of heat and electricity. Non-metals are poor conductors. Metals are sonorous, whereas non-metals are not. Metals react with oxygen to form metal oxides, which are basic in nature. Non-metals react with oxygen to produce non-metallic oxide, which are acidic in nature. Most metals react with water to form metal oxides or metal hydroxide, and hydrogen gas is produced. Generally, non-metals do not react with water. Most metals react with acids to produce salt and hydrogen gas. Non-metals do not react with acids. Some metals react with bases. A more reactive metal can displace a less reactive metal from its salt solution, and the reaction is called displacement reaction. Both metals and non-metals are widely used in daily life. So now let's see some keywords. So the first is our metal, the element whose atoms readily lose electron to form cations are called metals. Non-metals, the element whose atoms readily accept electrons to form anions are called non-metals. Next is your ores. The minerals from which metal can profitably extracted are called ores. The process of obtaining a pure metals arranged from one of it from R is known as metallurgy. Reactivity series. Reactivity series in a list of metal arranged in decreasing order of their reactivity. Next is a displacement reaction. The reaction in which the more reactive element displaces the less reactive element from their salt is called displacement reaction. Next is a corrosion. The degradation of metals to their oxides, hydroxide, sulfides on exposure to air and water is called corrosion. Next is a alloy. An alloy is a homogeneous mixture of two or more metal or non-metals. So that's all for this chapter. So now I will meet you in the next class with a new chapter. Till then, revise this chapter and keep learning. Thank you.